Hello everyone, I'm Pranav. My USN is 1VE20CA015. In this video, we'll be talking about the topic geothermal energy. Geothermal energy is the energy that lies embedded within the Earth's crust, otherwise known as any heat energy that is stored deep inside the Earth's crust in the form of volcanoes, geysers, or hot springs and boiling mud pots that are visible evidence of the great reservoirs. So this geothermal energy produces a low grade heat that is about 50 to 70 degrees Celsius, which can be used either for thermal applications, and occasionally it is also available in temperatures of around 90 degrees Celsius, which can be useful in production of electricity and also in other activities which involves turbines and can be contemplated. So geothermal power generation is a method of producing electricity using the Earth's natural heat. That is in the form, as we discussed, that is in the form of volcanoes, geysers, or hot springs. So, there are two ways in power generation using geothermal energy. That is, one is heat energy is transformed into working fluid, which operates the power cycle. So, power cycle is basically where the volcanic activity is occurring and the molten interior mass of Earth vents to the surface of the fissures. So here the temperatures lie between 450 to 550 degrees Celsius, and here the coil of pipes is embedded, and a stream of jet of water is sent through the pipes, through which it is converted into steam, and through the steam turbines are run and electricity is generated. Also, there is another method wherein the water or steam is used to operate the turbines directly from the well. So here, the pipes are of around 1 meter 1 meter in diameter, and the distance of the steam wells are up to 3 kilometers to the power station that lies above these steam wells. So the water separators are the condensers which separate the steam and the water in the station, and the moisture and solid particles are separated. The hot water is pumped from deep underground through a well in high pressure. This high pressure makes the water convert into steam, and steam spins the turbine, which is in turn connected to a generator that produces electricity. Once the steam cools off, it is condensed back into water, and the cooled water is pumped back into the Earth's surface. So, and the process is repeated again and again. So this is a cycle which keeps on occurring, and the process where there's almost no loss, and the electricity is being generated. And this is the proper depiction of the model that we just discussed about, where you can see the condensed water goes back into the earth. The cold water is sent back into the earth, and then the steam separator, which separates the solid particles and the steam and the water. So these are the steam wells that could be of 1 meter in diameter and go up to 2 kilometers deep in the Earth's surface. And the generator that is connected to the steam turbine which runs from the uh, high density of steam. So steam turbine is connected to the generator, which generates the electricity. That is the main objective of this model. So coming to the advantages. So geothermal energy is a reliable source that is it it can be present throughout the year. So, and also it could be unlimited, as in where like we saw in the model, the water can be reused. So there is not much loss in this. So it is available 24 hours a day. It is available independent of the weather, because of the nature's conditions. And geothermal power plants require little land area, not much, as it is confined to that area. So other advantages are renewable and sustainable. So we know it is renewable, it is inexhaustible, and it is a sustainable source, as it is not a man-made resource and it can be replenished. So, and there is low emissions in geothermal energy. Geothermal power plants produce very low emissions in terms of greenhouse gases in comparison with the fossil fuel power plants. And also the efficiency of the geothermal power plants are pretty high, that is up to 90%, which means they can produce power continuously. And like I said, it is reliable. Unlike solar and wind power, this runs throughout the year depending on the geolocation. So, other than that, the applications can be such as heating and cooling buildings, industrial processes, and also agricultural applications. Coming to the disadvantages, uh, the heat is a low grade heat that could not be meddled. So, other than that, continuous extraction of heated groundwater may lead to subsidence or slumping of land, or even loss of water or intoxication of water. Also, drilling operation leads to noise pollution, which could also be a disadvantage. And thermal energy cannot be distributed easily over long distances. Other than that, the fluid, that is the uh, fluid released into the water, might reduce the life of plants in the nearby areas, and it could be corrosive. And because of direct heat use, uh, there could be a loss of vegetation in that area. Other than that, there are a few constraints that is limited to the location, as geothermal energy can be extracted and converted into the other resources such as electricity generation only in the places where it is available. So it might not be available in all the regions, so it depends. And there are high capital costs, that is setting up the plants and running them and having a maintenance, uh, having to have a maintenance on these plants and constantly generate the resources that we need, can be expensive and financially less viable. And also environmental impact, it could have negative impacts such as release of gases and minerals from underground reservoirs, or the water that is being cycled in and out in the production of electrical energy. And also limited lifespan, so the wear and tear might happen in the geothermal power plants, and investment is again an issue. So, coming to the applications, electricity generation. So geothermal energy is primarily mainly used for electricity generation, and other than that, there are also other applications such as heating and cooling. So in this, heating and cooling of buildings is done, and particularly in areas where hot springs or geysers exist. So these can be located in places like South Africa or Malay. So industrial processes. Uh, Geothermal energy can also be used in industrial processes such as food processing, desalination, and mineral extraction. Desalination, wherein industries are set up in springs and salt is removed or extracted from the saline water. And also agricultural purposes such as greenhouse heating, crop drying, and aquaculture. So, thank you for watching the video, guys.